In this video I'm going to show you how to build an insanely bright LED panel. Now this is mostly for video work like I'm doing now, and I've used it quite a lot since I've built it. The main advantage is that it is, well, super bright. It uses about 100 watts of electricity, which is equivalent to I think about 1,000 watts if it was a normal light bulb, so that's a kilowatt of light output, which is incredible. Another advantage is that it costs not that much to make. I mean, if you wanted a panel of this brightness, you'd be looking at £300 to spend, which is I think about $600, but this actually cost £40 to build, which is around $70 or so. So very budget friendly. Another bonus is that because it uses voltage regulation, it doesn't flicker. So it means that you don't get any strobing lines on the footage, which can be a problem with some panels that use pulse width modulation. And a side bonus of it using voltage based dimming is that you can use a variety of different power sources to power it. So you can use laptop adapters, for example, and LiPo batteries and all sorts of things like that. So it really is ideal for sort of budget productions and things. And it's not actually that hard to build either. It just it doesn't take too long. So if you want to build one yourself, or if you're even just interested in seeing how it was built, continue watching and I'll show you everything involved. For this project you'll need the following items, all of which are listed in the video's description for convenience. The main component for this build is 3 5-meter strips of neutral white LEDs. These specific LEDs are pretty much pure white with no blue or yellow tint. Other important components include a voltage regulator, 2 meters of 12 American wire gauge paired wire, some magnet wire, one large sheet of 6mm thick MDF, and a smaller sheet of 18mm thick MDF. You'll also need the following tools. So the first thing to do is to build the frame, starting with the tripod mount. So get a camera shoe mount adapter and trim off the excess plastic around the thread on the bottom using a hacksaw. Next, cut out 2 35 by 100mm rectangles, one out of 6mm MDF and the other out of 18mm MDF. Drill a hole in the centre of the thinner rectangle for the trimmed shoe adapter to fit through, using a coping saw or file to make it square. Next, use a chisel to dig out a hole in the thicker rectangle for the shoe adapter to fit into, and use some glue to stick it all together. Next, cut out a 55 by 35cm sheet out of 6mm MDF. This is going to be the main structural panel. Now clamp the tripod mount to the middle of one of the longer edges of this panel with the tripod thread facing outwards, and drill 2 holes through the panel and into the tripod mount. These are pilot holes for screws, but before screwing them in, add some glue to the tripod mount for extra strength. Make sure you countersink the screws beforehand so that the screws end up flush with the front of the panel. Now it's time to work on the handles. I used aluminium tubes for this as I had a few lying around, but wooden dowels should work just as well. So cut down your aluminium tubes or dowel to make 2 lengths measuring 27cm long and 1 length measuring 47cm long. Next, cut 6 blocks out of 18mm thick MDF. These need to be around 6cm high and 2cm wide. As they're going to be supports for the handles, you'll need to drill a hole into each for the handles to slot into. Once you're happy with the positioning, drill some pilot holes into the bottom of each support block and a corresponding hole through the back panel. Secure each block in place using some wood glue and a screw. To prevent the blocks from splitting as the screw goes in, you may want to squeeze the block with a clamp. Just as before, remember to countersink each hole on the front of the panel so that the screws end up flush with the surface. You may also want to glue in the handles to prevent them from twisting once it's all dry. Now it's time to add the wires for the LEDs. What you'll need for this are 2 lengths of thick paired wire, each about 1 meter long. They need to be thick so that they can supply the current needed by the LEDs, and I recommend that you use at least 12 American wire gauge wire. After stripping off about 16 centimeters of insulation from one end of the wires, Drill 2 holes on each side of the panel and thread them through, making sure that the stripped ends of the wires are on the front side of the panel. Position them splaying outwards from the centre and use staples to keep them in place. Each side is going to have its own polarity, so it doesn't matter if they touch at the middle point. Now it's time to add the LEDs to the panel. So what you need to do is cut your strips of LEDs into 50cm lengths. Always make sure that you cut between the copper pads, which are between every 3 LEDs. Once you're done, you should have 30 individual strips. In order to solder wires to the strips, you'll need to bend back and cut off the waterproofing material from each end, leaving the solder points exposed. Now they're ready to stick to the panel, but first draw a horizontal dividing line on the front panel to help you keep things straight. Peeling off the tape cover on the back, stick the first strip just to one side of this line. Do the same with the next strip, but offset it so that the LEDs start to make a checkerboard pattern. Continue this process until you've stuck on all your strips. Now it's time to connect the strips to the large wires we added earlier. What you'll need for this is some magnet wire, also called enamelled wire. You can of course use normal insulated wire, but it's much more time consuming as you'll have to manually remove the insulation as you go. On the left side of the panel, solder this magnet wire to each of the positive marked contacts on the strips. As you go along, trim the magnet wire at the point where it passes over the thick wire we added earlier. Once you're done, solder the trimmed ends to this thick wire. After you've finished the left side of the panel, move around to the right side and follow the same procedure, but this time using the negative marked contacts on the strips. Once you've finished, you may want to try hooking it up to a 12-volt power source to check for any loose connections. Keep in mind that it may appear dim at this point unless you use a power brick capable of supplying at least 10 amps. Once you've confirmed that there are no loose connections, cut some lengths of 6mm MDF to make a border about 1.5 cm high around the edges of the panel, using wood glue to keep it in place. Leave a gap along the top edge so you have the option of sliding in coloured filters when it's finished. It also helps keep the LEDs cool. Now you can paint the whole panel. I chose white, but you can choose any colour you like. To help reflect light off the border, I added some reflective tape along the edges. Honestly, this really doesn't do much, so only bother with it if you happen to have some reflective tape lying around. Keep in mind that you'll need to stick on some electrical tape first to prevent the reflective tape from causing any shorts. Now it's time to add a plexiglass front to protect the LEDs. To trim it down, accurately mark the size you need and score it using a sharp knife. After making a significant groove, you can then squeeze the plexiglass between two surfaces and push downwards on the piece you want to break off using something to spread your pressure. If you don't use something to spread your pressure, you may end up with an uneven break. However, these pieces can still be put to good use, as I demonstrated in my shard light video, which utilised these broken pieces. Next, you need to drill some holes into the plexiglass and then use some screws to screw it to the border we added earlier. So now the panel is almost complete, but the last thing to work on is the dimmer circuit, which is based on a voltage regulator. A lot of LED panels use pulse width modulation circuits for dimming, which works by flashing the LEDs on and off extremely quickly. Although this is more efficient in regards to power usage, it can cause some strobing lines when recording video, which is why voltage dimming is a better choice, as the power remains solid. The voltage regulator takes an input voltage and regulates it down depending on the setting of a micropotentiometer. As the voltage range of the LEDs is between 6 and 12 volts, we need to limit the voltage regulator to output voltage only within this range. To do this is quite simple. All we need to do is solder the left pin and the middle pin of a 22K potentiometer to these corresponding pins on the voltage regulator. However, we need to solder a 6.8K resistor in line with the 22K potentiometer. This resistor sets the minimum resistance of the circuit and therefore the minimum voltage, which is around 6 volts. So now that the minimum voltage has been set, we need to make sure that the maximum voltage never exceeds 12 volts. We need to monitor the regulator's output for this, so hook up a multimeter to its output and connect the regulator to a 15 volt or greater power source, like a laptop adapter. So turn the 22K pot fully clockwise and the micro pot on the voltage regulator fully anti-clockwise. Now slowly turn the regulator's micropotentiometer clockwise until the output hits 12 volts. As soon as it hits 12 volts, stop turning. Over-adjusting this micro pot may damage the LEDs because of too much voltage. Now check the voltage range by twisting the 22K pot, and it should smoothly adjust the voltage from 6 volts to 12 volts, regardless of whether you use a 12 volt input or a 30 volt input, or anything in between. Now solder on a female XT60 connector and a switch to the regulator's input. Why an XT60 connector? Well, this type of connector is well suited for high current applications, and it is frequently used with LiPo batteries. Remember to use heat shrink over the solder joints to protect against power shorts. Now make a little enclosure for it out of MDF, but make sure you leave the heat sinks exposed as they will get quite hot. Now you can solder the LED panel's power wires to the regulator's output. Make sure that you get the polarity correct and use plenty of electrical tape between the wires to prevent any shorts. Although not pictured here, solder 2 more small wires to these same contact points, as they're going to power a small fan to keep the regulator's temperature in check. Now you can glue the dimmer circuit to the back of the panel, just above the tripod mount. As a finishing touch, push a nice looking knob onto the potentiometer. So the last thing to do is add a fan to the regulator's left heatsink, which is the one that gets quite hot. To do this, simply solder a fan to those small wires I mentioned earlier, and glue it in place. As my fan was rated at 5 volts, I added some resistors in series with it to reduce the voltage. This also makes it quite quiet, as it doesn't have to push a lot of air to cool down the heatsink, which dissipates at most about 10 watts. As you can see, I mounted it on some sponge to further reduce the noise by eliminating vibrations. This is a concept I also covered in my How to Make a Graphics Card Quieter video. To power the panel, you can either use an AC adapter or a battery. The voltage can be anywhere from 12 volts to 30 volts, but the power source has to be capable of delivering at least 100 watts for maximum brightness. 3-cell LiPo batteries are quite a good option because they are able to deliver high currents and usually have a pretty high capacity. However, do note that you'll have to have a low voltage cutoff circuit to prevent the battery from being over-discharged during use. I built my circuit into a custom 8 amp battery pack, which disconnects itself when the voltage drops below a set value. While it is beyond the scope of this video, I will be making a video about this circuit soon. In the meantime, the simplest way of protecting a LiPo battery is to use a LiPo alarm, which beeps loudly when the power is running low. If it hasn't got one already, remember to solder on a male XT60 connector to the power source you want to use. If you want, you can make little adapters so that you can hook it up to laptop power supplies, for example, without replacing the connectors. So, the panel is now complete. I hope you have success in creating your own, and I also hope you'll consider subscribing if you haven't already. In case you missed it, why not check out my previous video in which I show you how to make a DSLR video ring light. I hope I see you there.